Good day, everyone. Welcome to Jamovi for Educational Research Tutorial Series, Episode 2, Descriptive Statistics. What do we mean by descriptive statistics? Descriptive statistics is a term given to the analysis of data that helps describe, show, or summarize data in a meaningful way such that, for example, patterns might emerge from the data. Descriptive statistics do not, however, allow us to make conclusions beyond the data we have analyzed or reach conclusions regarding any hypothesis we might have made. They are simply a way to describe our data. Descriptive statistics are very important because if we simply presented our raw data, it would be hard to visualize what the data was showing, especially if there was a lot of it. Descriptive statistics therefore enable us to present the data in a more meaningful way, which allows simpler interpretation of the data. There are various types of statistics that are used to describe data. We have measures of central tendency, measures of dispersion, percentile values, measures of distribution, and descriptive plots. And we will go through this one by one in the Jamovi software. First thing that we should do, of course, is to import the dataset that we will be using in this tutorial. So let's have this sample data where a teacher wants to describe the motivation of students. So we have here sets of data for sex, type of school, year level, and their score on motivation, which was gathered maybe from a scale. Let's start by clicking the exploration and then descriptives. So this is how it looks like. Let us transfer motivation here. And then, for example, you want to split it by sex, male and female. So this is the default that you will see. Let us now click Statistics. So you have noticed some options were already checked, and that's actually the default. I will untick everything first, and we will try to discuss it one by one. So let's start with the sample size, which will show the frequency. And if we click missing, it will tell you if you have some missing data from the participants. We can uncheck that. So we can see the number of male and female we have in the respondents. Let's try to add other variables. So this is what we call cross-tabulation. So we can now see how many male and female we have from public and private schools. Let's then add a year level. So it now gives us information about the number of students per level from public and private separated by sex. Let's now move to the next one, but let's just focus only in one variable. So let's now proceed to measures of central tendency consisting of the mean, median, and mode. So measures of central tendency estimate the center or average of a dataset. We use this for describing the central position of a frequency distribution for a group of data. The mean, median, and mode are the three ways of finding the average. Let's start with the mean. It is the commonly used method for finding the average. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean has actually one main disadvantage. It is particularly susceptible to the influence of outliers. These are values that are unusual compared to the rest of the dataset by being especially small or large in numerical value. As for the median, it is the middle value in a dataset that has been ordered from the smallest to largest value, and is the normal measure used for ordinal or non-parametric continuous data. It's also less sensitive to outliers and skewed data. Lastly, we have the mode. It is the most frequent value in the dataset, so a dataset can have no mode, one mode, or more than one mode. Let's now unclick everything and let's proceed to percentile values. Percentiles indicate the percentage of scores that fall below a particular value. They tell you where a score stands relative to other score. For example, a person with an IQ of 120 is at the 91st percentile, which indicates that their IQ is higher than 91% of other scores. If we click Cut Points 4, we can classify the respondents based on the norm reference criteria. For example, let's have 3 groups. So these groups may represent low, average, and high motivation. And let's look at the results. As you can see, Jamovi provides the value for the 33.33 percentile, which corresponds to the cutoff score in determining the scores of the respondents with low motivation. Moreover, the score is higher than 33.33 percentile but lower than the 66.67 percentile indicate average motivation, and the scores higher than 66.67 percentile indicate high motivation. Jamovi also has an option where you can put the percentile that you want and you will have the cutoff score corresponding to that percentile, and that is by clicking this one. The widely used application of this is for the college entrance exam, where for example a university only wants to accept the examinees who belong to the top 10% or those in the 90th percentile. Let's now uncheck it and move to dispersion. So what do we mean by dispersion? Dispersion, which is also known as measures of variability or spread, gives you a sense of how spread out the response values are. Let us check everything for a while. And let me briefly discuss each one of those. Minimum and maximum. So this set refers to the minimum value and maximum value. Like for example, in our dataset, the lowest and highest score. We also have standard deviation and variance. Standard deviation is used to quantify the amount of dispersion of data values around the mean. A low standard deviation indicates that the values are too close to the mean, while a high standard deviation indicates that the values are dispersed over a wider range. While variance, it is another estimate of how far the data is spread from the mean. It is also the square of the standard deviation. So what's the difference between the two? Do we need to use both? Actually, not really. The standard deviation is expressed in the same units as the mean is, whereas the variance is expressed in squared units. But when looking at the distribution, you can use either just as long as you are clear about what you are using. Though they each have different purposes, standard deviation is usually more useful to describe the variability of the data, while the variance is usually much more useful mathematically. And you don't really need both. If you report one, you don't need to report the other. For the range and IQR, range simply gives you an idea of how far apart the most extreme response scores are, while IQR, or inner quartile range, describes the middle 50% of values when ordered from lowest to highest. Lastly, we have the SE mean, or standard error of mean. It is a measure of how far the sample mean of the data is expected to be from the true population mean. As the size of the sample data grows larger, the standard error of mean decreases compared to standard deviation, and the true mean of the population is known with greater specificity. Take note that you don't actually have to check everything here. Checking SD alone or SD and standard error of mean is enough. Let's now move to distribution. So let's click both Skewness and Kurtosis. This describes the shift of the distribution away from a normal distribution. Negative skewness shows that the mode moves to the right, resulting in a dominant left tail. while positive skewness shows that the mode moves to the left, resulting in a dominant right tail. For skewness, if the value is greater than positive 1, the distribution is right skewed. If the value is less than negative 1, the distribution is left skewed. Kurtosis describes how heavy or light the tails are. Positive kurtosis results in an increase in the pointiness of the distribution with heavy or longer tails, while negative kurtosis exhibit a much more uniform or flatter distribution with light or shorter tails. And for the kurtosis, if the value is greater than positive 1, the distribution is leptokurtic. And if the value is less than negative 1, the distribution is platykurtic. Let's now go to normality. So let's unclick this and click Shapiro weak. The Shapiro weak test is a way to tell if a random sample comes from a normal distribution. Shapiro weak P corresponds to the significance of Shapiro weak W. It should not be significant, or the value must be greater than 0.05 for us to say that the data is normally distributed. What will happen if we click everything? So let's see. So this is what you will see. Make sure that when you're running descriptive statistics, it's clear to you what you'll only need. Now move to the plots. So we have histogram, box plots, bar plots, and QQ plots. So these are basically examples of what we call statistical graphics, which are used to visualize quantitative data. Whereas statistics and data analysis procedures generally yield their output in numeric or tabular form, graphical techniques allow such results to be displayed in some sort of pictorial form. But take note that not all datasets require a plot. Let's click first the histogram. So a histogram is the most commonly used graph to show frequency distributions. It looks very much like a bar chart, but there are important differences between them. We use histogram when the dataset is numerical, and if you want to see the shape of the data's distribution, especially when determining whether the output of a process is distributed approximately normally. However, visualizing normality using histogram is very challenging for a researcher when the sample size is not large enough. So to cope with this, it's also good to practice clicking density. So let's click density. So it's for better visualization of normality. Based on Shapiro-Wick's result in this dataset, the motivation scores of female are normally distributed, while the motivation scores of male are not. This finding can also be derived from the histogram and density plot. Next is Backsplat. It is used to determine if there are any significant outliers in the dataset. The dots above or below the line. So in this example, we have 2 dots above the line. So these dots indicate the existence of significant outliers. Backsplots also visualize median value and interquartile range. You must take caution in deciding whether to remove or retain the significant outlier. Next, click Violin and Jitter elements. The Violin plot has taken the smooth distribution curve from the distribution plot, rotated it 90 degrees, and superimposed it on the box plot. The Jitter plot has further added all the data points. One is bar plot, which is used to compare the mean. Lastly, we have the QQ plot, which has the same purpose with histogram. When the dataset is approximately normally distributed, the points must lie on the line. Otherwise, as seen in the QQ plot of male, the dataset is not normal. And that ends this session. Thank you for watching Jamovi for Educational Research Tutorial Series. Stay tuned for the next episode. See you next time!